Houston is getting a factory that isn't just promising to make cars, it's about to rewrite the laws of thermodynamics on wheels. Tesla is completing its third megafactory by 2026, and this time, the focus isn't just on the vehicle, but on what powers it inside. An aluminum-ion battery. It may sound like just another technical term, but what it contains has the potential to be a game-changer. The big advantage? It promises to run cool, charge quickly, and last longer. And in a world where heat means wear and tear, that's like putting ice in an engine without killing its power. This innovative thermal architecture addresses the heart of electric car problems: overheating. Every time someone accelerates or plugs the car into a powerful charger, the temperature rises, and with it, degradation. But this new battery uses a completely different approach. Instead of a system that attempts to manage the heat generated, the idea here is to prevent it from occurring in the first place. The structure uses an aluminum anode, a carbonaceous cathode, and a chloroaluminate electrolyte, the trio that sets the tone for this revolution. And it's not just any electrolyte. We're talking about an ionic liquid that, besides being non-flammable, practically doesn't evaporate. This means it can operate under high voltages and aggressive loads without becoming a thermal time bomb inside the car. Its high ionic conductivity at room temperature allows energy to flow without creating bottlenecks, without the suffocating heat that usually comes with rushing. It's like opening a wide avenue for ions to circulate without traffic jams or friction. This completely changes the logic of accelerated wear. Normally, heat causes the cell's internal interfaces to thicken, the materials to wear, and internal resistance to increase. It's a vicious cycle. More heat generates more wear, which generates more heat. But in this new arrangement with aluminum, the cell runs cooler from the start. And when there's less heat to extinguish, the internal materials breathe a sigh of relief and live longer. These improvements may seem like technical details, but the impact on everyday life is enormous. A car with this battery won't feel the heat of a Texas summer, even during a quick recharge. That feeling that your car gets tired over time, losing performance and range, tends to disappear. Because a cell that doesn't heat up also doesn't age as quickly, which means fewer unexpected visits to the repair shop and more years of stable performance. And the driver experience changes in almost invisible but extremely significant ways. There's no need to worry about the battery's condition or whether that emergency charge will shorten the system's lifespan. Everything works as it should, without tricks, manual adjustments, or surprises. The feeling is that the car better understands its own rhythm and responds with stability, even in extreme situations. Another interesting point is reliability. With less accumulated heat, the thermal sensors, the management system, and the protection modules work more freely. This not only reduces the chance of failure but also makes the system more predictable and safe. And when it comes to onboard technology, predictability is synonymous with reliability, something EV owners increasingly value. Even with so many promises, it's worth remembering that we're talking about a project that still needs to be proven at scale. But if Tesla can deliver these batteries to the assembly line without compromising their thermal and safety properties, it could very well make a leap forward that would leave any combustion engine competitor looking like a museum piece. The big bet now is whether this technology can leave the lab and face the real world without losing its cool. Despite all the brilliance of this innovation, the transition from theory to practice is where the game becomes more challenging. Tesla's aluminum-ion battery relies on an extremely moisture-sensitive electrolyte, chloroaluminate, which is hygroscopic, meaning it readily absorbs water from the environment. This may seem like a technical detail, but in terms of mass production, it means each cell must be carefully sealed to prevent it from coming into contact with air. A minor sealing failure can compromise the entire battery pack. The margin for error is minimal, and any oversight can be costly. This sealing complexity involves not only the battery's outer casing, but everything that comes into contact with the electrolyte. Gaskets, connectors, current collectors, and even the environment where the battery is manufactured must be designed to prevent any trace of moisture. The manufacturing process, already sophisticated with lithium, becomes even more demanding with aluminum. This requires environments with controlled atmospheres, continuous monitoring, and highly chemically resistant materials. But by overcoming these engineering hurdles, the benefits begin to show where drivers feel them most: in maintenance. With less heat generated and less stress on internal materials, the system as a whole ages more slowly. This translates into fewer heat-related failures, such as loss of power, charging failures, or activation of protection systems. In other words, fewer unpleasant surprises and fewer unexpected visits to the repair shop. The battery starts to work so steadily that it practically disappears from the car owner's list of concerns. Extended durability has a direct impact on warranties offered. Today, most electric vehicles already have warranties of up to 8 or 10 years for their battery systems, but with this new architecture, it's possible to imagine even more generous coverage. After all, if thermal degradation is reduced by half, the actual wear and tear on the cell over time also decreases. And this changes how consumers perceive the value of the vehicle. It's not just a car, but a safer and lower-risk investment over the years. Furthermore, there's a more subtle but significant financial impact: the cost of corrective maintenance. Many minor repairs in EVs are related to accumulated heat, whether in the cooling system, charging interfaces, or even the battery's electronic management. By reducing the source of these problems, the aluminum-ion battery acts as a shield against cascading failures. And this represents real savings over time, without the driver needing to understand exactly how the system works. Another little discussed but noteworthy point is service predictability. Authorized repair shops can operate more quickly if diagnoses are clearer and problems are less frequent. Less thermal variability means fewer anomalies and intermittent failures, which are difficult to detect and resolve. The result is shorter wait times and lower maintenance costs, a crucial factor for those who rely on their cars every day. All of this reinforces the idea that the future of electric vehicle maintenance is directly linked to battery performance. And if Tesla can deliver a system that operates with less heat, less wear, and more consistency, it will not only simplify the consumer's life, but also redefine what reliability means in a modern car. The challenge now is to ensure that this battery not only performs well in tests, but also maintains the same performance in everyday use, under sun, rain, and everything the road throws at it. And if this technology truly takes hold, the impact could go beyond Tesla. Suppliers, repair shops, insurers, and even aftermarket networks will have to adapt to a new standard of durability. Because when heat is no longer an enemy, everything around it needs to keep pace with a car that simply doesn't break down. With heat under control and maintenance less of a headache, another sector beginning to feel the impact of the new aluminum-ion battery is insurance. Many people don't realize this, but today, electric cars still pay higher premiums than combustion-powered models. And the main reason lies in the battery. It's not that EVs catch fire more often. In fact, data shows they're even safer in this regard. But when something goes wrong with the battery, the losses are often significant. A fire or structural damage often results in the total loss of the vehicle. And this weighs heavily on the policyholder's pocket. Insurance companies' logic is simple. They work with two variables: frequency and severity. In other words, how often something happens and how expensive it is when it does. And even though modern batteries are stable, the rare instances in which they fail are so costly that they drive up the average. But with Tesla's new system, this equation begins to change. The battery's composition, more heat-resistant and less flammable, drastically reduces the chance of a failure turning into a disaster. In addition to chemical safety, more efficient thermal control also reduces collateral damage in the event of a collision. When a battery overheats after an impact, the chance of a secondary fire increases. But if the system stays cool, even under stress, the consequences are milder, and the car is easier to recover. This means fewer total loss claims and a greater chance of repair. And each successful repair lowers insurance premiums, making EVs more affordable in the long run. Another important point is predictability. For insurers, the worst-case scenario is uncertainty. If you don't know exactly how the system will react in a crash, you have to charge more to protect yourself. But if Tesla's new battery proves to be consistent, heat-resistant, and non-combustible, insurers may begin to reconsider their policies. The result? Lower-cost policies and fewer restrictive clauses related to heat damage or water intrusion. In fact, coverages are beginning to resemble those for traditional cars. The well-known exclusions for battery damage, thermal propagation, or internal short circuit due to overload may disappear or become less stringent. This provides greater security for those buying the car and also greater confidence for those reselling it, knowing that the vehicle doesn't carry the stigma of being expensive to insure. All of this stems from trust in a system that operates cool, with low volatility and superior chemical resistance. At the end of the chain, even repair shops benefit. When the risk of fire is lower, safety protocols are simplified, and labor time is reduced. Today, many EV repairs require dedicated areas, specific training, and component isolation, all due to the battery. But while Tesla's new system shows that this risk is decreasing, procedures are closer to those used in combustion engine cars, which reduces service costs and speeds up delivery times. This shift in the scenario is also reflected in the used car market. Cars with a history of low accident severity are more valued by consumers, auctions, and fleet owners alike. If the aluminum-ion battery truly reduces the incidence of total losses and facilitates repairs, models equipped with it will have a clear advantage in the secondary market. And this creates a virtuous cycle. Lower risk leads to cheaper insurance, which generates more sales, which stimulates greater competitiveness in the sector. With less heat, less risk, and more predictable maintenance, the next advantage jumps straight into drivers' daily lives: charging time. Anyone who's ever owned an electric car knows that recharging is different from filling up with gasoline, and not just from a plug. Lithium-ion batteries need to reduce charging power as they fill up, precisely to avoid overheating. This causes charging to slow down in the last 20 to 30% and ends up taking up more space. The result is longer lines and less efficiency at fast charging stations, especially during peak hours. But the aluminum-ion battery enters this equation with a bold proposal: maintaining high power for longer, without generating unwanted heat. This means shorter, less variable charging sessions. For the driver, the feeling is clear. You stop, plug it in, and in about 15 minutes, you've already recovered up to 80% of the battery. No more waiting around or seeing the estimated time increase mid-charge. This predictability transforms the entire dynamic of using an electric car on a daily basis. Furthermore, the charging network also benefits. When each car occupies the station for less time, the number of recharges per hour increases. This means the same stations can serve more people without requiring massive investments in new infrastructure. For network operators, it's pure efficiency. For drivers, it means shorter lines and less frustration. The experience becomes similar to that of a gas station: fast, convenient, and without surprises. And there's a significant psychological effect to all this. When waiting times decrease and recharging becomes a reliable process, people relax. Planning long trips with an EV stops being a series of stops and starts to feel like a simple coffee break. You plan your route knowing you'll stop for 12 or 15 minutes without having to arrive with a nearly dead battery or wait forever for a free spot. This completely changes the perception of convenience. This improvement also impacts fleets and commercial vehicles. Operators who need to keep cars running all day such as taxis, delivery services, and corporate transportation, see an operational advantage in aluminum batteries. More recharges in less time means more hours on the road and less downtime. And when the operation is large, every minute saved translates into money. This optimization can even reduce the number of vehicles needed to meet the same demand, simply because downtime drops dramatically. Another interesting point is its compatibility with existing infrastructure. The new battery doesn't require special chargers or non-standard high-power stations. It can draw more from the current grid while maintaining performance without the need for costly upgrades. This is a relief for cities, businesses, and drivers who have already invested in chargers and don't want to replace everything just to keep up with technological advancements. For those who live in apartments, park on the street, or don't have easy access to chargers at home, this solution is even more valuable. With a weekly recharge, done during grocery shopping or a break at the mall, the car is always ready. The dependence on a household outlet disappears, and the EV becomes a better fit for the routine of those living in urban centers. It's a democratization of the electric car, achieved not with rhetoric, but with engineering that solves the right problem. And while faster charging already improves the driver's life, maintaining the car's value over the years can be even more crucial. In today's market, electric vehicles tend to lose value faster than combustion-powered models, and this has nothing to do with looks or performance. It's the uncertainty surrounding the battery that weighs heavily. Many used car buyers are hesitant, imagining that they might need to replace the entire package within a few years, which could cost almost the price of the car itself. This uncertainty affects resale prices, financing options, and even brand trust. But with the aluminum-ion battery, this scenario begins to change. Because it operates at lower temperatures and degrades more slowly, the cell's capacity remains more stable over the years. This means that, even after 6 or 8 years of use, the car still delivers reliable, trouble-free range. And when consumers know their vehicle will remain useful for longer, resale value increases. It's that simple. Risk decreases, confidence increases, and the market responds with better offers. This positive perception also affects banks and financial institutions. When the asset, in this case the car, has a higher expected future value, financing options can be more aggressive. Lower interest rates, longer terms, and reduced down payments become viable because the vehicle tends to maintain its market value. The Model 2, already targeting a more price-sensitive audience, gains a decisive advantage from this. Buying the car becomes more affordable, and exchanging it for a new one in the future is no longer a headache. Furthermore, buyback, leasing, and subscription car programs also benefit. Fleets that renew their vehicles every 3 or 4 years will see a jump in profitability if they can resell used models at a higher value. And again, all of this happens because the heart of the car, the battery, doesn't melt over time. A smoother degradation curve even allows for more transparent warranty standards for used cars, attracting more buyers to the pre-owned market. This ripple effect even reaches insurance companies. With a lower risk of failure and higher residual value, companies can create specific products for EVs with aluminum batteries. Extended coverage, lower deductibles, and even bonuses for good use can emerge, making the overall package more attractive. All of this creates an environment where owning an electric car is no longer synonymous with worry or depreciation, but with stability and a real advantage for your wallet. The average consumer may not even notice all this machinery working behind the scenes, but they'll feel it firsthand. Fewer installments, more affordable interest rates, and a sense that the car they buy today will still be valuable tomorrow. This creates a cultural shift. People stop seeing EVs as gadgets on wheels and start treating them as solid, reliable assets that can be passed on without fear. And it's precisely this maturity of perception that's needed for electric cars to truly take off in more conservative markets. Even certified pre-owned vehicle programs are gaining momentum. With slower, more predictable degradation, Dealerships can offer extended warranties without fear. Usage history becomes more relevant than the car's age, and buyers feel more confident buying a pre-owned Tesla, knowing that the range and performance are still there. This moves the market, expands the target audience, and speeds up the purchase and resale cycle. This is the true power of a battery that doesn't wear out quickly.